In this video, we're going to look at what I call the basic grammar of algebra. We're going to look at essential skills and properties of the real number system that allow us to simplify algebraic expressions. Before we take a look at a typical example, I want to look at this numerically. Suppose a parent wrote this on their kid's 21st birthday cake. Is it correct? Happy 3 times the quantity 5 plus 2 birthday. Technically, yes, because according to the order of operations, we would do that sum first. And when you put the 3 up against that sum, that means you're multiplying those two things, and 3 times 7 is 21. So technically, this is the same thing as saying happy 21st birthday. However, we wouldn't do that. In general, you always want things in simplest form, especially when you have to keep working with something over and over and over again. I'd much rather see this expression than this expression, even though they are equivalent. That's essentially what we're going to be working on here. Again, we want to look at the basic grammar of algebraic computation, which is often referred to as combining like terms. Here we have a typical example. We want to show that this expression right here is equivalent to this expression for all real values of the variable x. Before we even begin to analyze any of this, wouldn't you agree that this expression is much simpler to look at than this one? We need to establish that these two expressions are equivalent for all real values of x. First, do you recall how many real numbers there are in the set of real numbers? Well, there are infinitely many of them. So we cannot pick specific values of x and plug them in to each of these expressions and then see if we get the exact same number once we do all the computations. So we can't do this numerically. We need to have a computational way to deal with these variable quantities. That is the issue of combining like terms. And you'll see some real number properties will mix in and play an important role here. It's worth stopping this video right now to see if you can show that this expression is exactly the same thing as this. However, we're not going to do that in this particular slide. We're going to build up to it. We're going to go through all the foundational pieces that we need to have in order to know exactly how to convert this expression to this simpler expression here. Let's start that journey. We will go all the way back to some basic arithmetic facts. So here's our question. Which of the following expressions are equivalent to one another? 5 plus positive 2, 5 plus negative 2, 5 minus positive 2, and 5 minus negative 2. Take a moment, pause the video here, and which of these are equivalent to one another? If you are not sure of the properties of our arithmetic with signed numbers, you could obviously plug each of these into a calculator. 5 plus positive 2 would give you 7, 5 plus negative 2 would give you 3, 5 minus positive 2 would give you 3, and 5 minus negative 2 would give you 7. So 5 plus positive 2 and 5 minus negative 2 are the same. And 5 plus negative 2 and 5 minus positive 2 are the same thing. Let's see if from here, if you can recall some basic arithmetic facts with signed numbers from your past. 5 plus positive 2 is the same thing as 5 minus negative 2. You may recall that adding a positive number is equivalent to subtracting a negative number. It's like adding on a good thing is the same thing essentially as taking away a bad thing. Though not scientifically rigorous in nature, it's a good way to help you remember that adding a positive number is equivalent to subtracting the negative version of that same number. And similarly, if you add on a negative number, that's the same thing as subtracting a positive number. These basic ideas from arithmetic play a very important role in combining like terms, as you will see very soon. Here you'll find those two arithmetic facts summarized. Adding a positive number and subtracting the negative version of that number are equivalent. Also, adding a negative number and subtracting the positive version of that same number are equivalent. Adding a positive and subtracting a negative are equivalent to one another, and adding a negative and subtracting a positive are equivalent to one another. These two things together imply that you can always change subtraction to addition. So you can always change subtraction to addition. You don't actually need subtraction. So with that in mind, let's see if you can write each of the following expressions with only addition. We're going to be using these two facts to write each of the following expressions with only addition. Let's start here with this expression 7x minus 4. So this is a subtraction of, technically, this 4 is a positive number. This is the operation between the 7x and the 4 is positive. People just often don't write in the positive sign when they write down the number. So we have 7x minus positive 4. How can we rewrite this subtraction problem as an addition problem? Well, we're subtracting a positive number, which is here, that is equivalent to adding the negative version of that number. So instead of subtracting positive 4, we want to add negative 4. So this is the same thing as 7x plus negative 4. These two expressions are exactly the same. This one's written with subtraction. This one is written with addition. Let's do the same thing over here. If you've got x squared minus 3x minus negative 1, again, this is a subtraction sign, so this 3 right here is positive. We just don't write it. So the term 3x is positive 3x. So we've got x squared minus positive 3x minus a negative 1. Well, just like over here, when you subtract a positive, you could rewrite that as adding a negative. So we could rewrite this as x squared plus negative 3x. And now we're subtracting a negative number. We saw over here that subtracting a negative number is equivalent to adding the positive version of that number. So subtracting negative 1 is the same thing as adding positive 1. And I'm not even going to write in the positive sign. I'm just going to write 1, because when you write in 1, it's assumed that that is the positive version of the number. So this expression, x squared plus negative 3x plus 1, is equivalent to the original expression, x squared minus 3x minus negative 1. Now, we're not making a judgment here on which one looks simpler by any means. We're just pointing out that every subtraction problem can actually be written as an equivalent addition problem. You'll see the importance of this soon. Right from the beginning here, I said that this is the operation of subtraction. You've got 7x minus 4. So what exactly is subtraction? Why is that not a negative sign? Well, subtraction is a binary operation, which means it takes place between two mathematical objects. So in this case, the mathematical objects are 7x and 4, and the operation between them is subtraction. Subtraction is a binary operation, meaning it takes place between two mathematical objects. So the next question is, can you rewrite this sign as addition? We rewrote these subtractions up here as additions, but can you write this as addition? And the answer is no, because this is not a subtraction sign. There is no mathematical object right here. Remember, subtraction is a binary operation, meaning it takes place between two, bi means two, between two mathematical objects. Well, there is no mathematical objects right here. So this is not a subtraction sign. Well, as you know, technically it's a negative sign, yet we use the same exact notation for subtraction and for a negative sign. Let's dive into this a bit deeper. We want to analyze this numeric expression to describe all the ways the minus sign, or the dash, is used in mathematics. We've discussed so far, we've got subtractions, we've got negative signs. Let's first start with subtraction. Are any of these three dash signs, which we often just refer to as a minus sign, do any of them represent subtraction? Again, subtraction is a binary operation between two mathematical objects. So clearly this can't be subtraction. There's nothing up here. Is this a subtraction? Well, if this is a subtraction, that would mean you're subtracting 8 from a left parenthesis. That doesn't quite sound right. So this also is not a subtraction. Is this a subtraction? In this case, yes, you've got this number, subtract this number from it. So we've got a subtraction sign here. Well, what about the other two? Now, many students would say, okay, this is a negative sign because you've got a negative 8, and then this is also a negative sign saying you've got the negative of this expression. And that's not necessarily wrong, but I want to analyze it a little bit further. I completely agree with you that this sign right here is telling you you have a negative 8. So let's first write in that this is a negative sign here. And yes, you can think of this as a negative sign and you would not be wrong, but I want to challenge you a little bit. What does that mean to say that this thing in parentheses is negative? Does it mean the final result is a negative number? Well, let's answer that question by actually doing the arithmetic here. Now, by the order of operations, we would take care of the operation in parentheses. So we do this subtraction first. We've got negative 8 minus 4, which is negative 12. So I'm going to rewrite this exact same expression, but with negative 12 in place of this negative 8 minus 4. So you've got this sign out front, the parenthesis, and now we've got negative 12. Then what is this equivalent to? Many students would say a negative negative is a positive. And that's completely fine. This expression is equivalent to the number positive 12. But what do you mean by saying negative negative 12 is positive 12? Well, notice here, when we originally looked at this, you probably would call that a negative sign. And notice the final result is not a negative number. The final result is actually a positive number here. So in some sense, this negative sign, we could really think of it as just saying we want the opposite of whatever is in here in parentheses. So we got negative 12 in the parentheses. We want the opposite of the negative 12, which is positive 12. So we are now going to consider the dash symbol or the minus sign as possibly representing just the opposite of an expression. So while we can technically think of this as a negative sign, notice it did not give us a negative number. We don't want to get confused there. So right now I'm going to consider this to say we want the opposite of whatever is in parentheses. The opposite of negative 12 is positive 12. So we could potentially think of this sign as representing three different things, yet they're all the exact same sign: subtraction, negative sign, and an opposite sign. Let's dive into this idea of opposite further. To emphasize the importance of why we may want to consider that sign out front of that previous expression as an opposite sign rather than a negative sign, may possibly be pointed out in the following two examples. So we're going to do this one together just to make sure it's very clear what the instructions are here. And then I want you to try this example on your own and see what you get. So find the value of each expression for the given values of the variables. So we have the expression x plus y, and we want to consider what this expression is equivalent to when we have x is 2 and y is 3. So if we actually plug those numbers in, you've got 2 for x, then you've got that addition sign there, and you've got 3 for y, then clearly the sum x plus y is exactly 5 when x is 2 and y is 3. So it's literally plugging those numbers into the expression and simplifying. So you should now pause the video and do the same thing over here with this expression with these two values of x and y. What did you get? In my experience of teaching basic algebra over many, many semesters, I get either of two things here. Students either tell me that this is equal to 5 or that it's equal to 1. I think we can all agree that this expression for these two particular values of the variables can't possibly represent both 5 and 1 at the same time. So which one is it? Is it positive 5 or positive 1? Well, the actual answer is positive 5. For those of you who may have gotten 1 here, why is that? My belief in why that happens is actually in part because of how people read this expression. The most common way people read this expression is negative x plus y. And while that's not incorrect to say that, some people literally take this as saying negative x means that represents a negative number. So we're plugging in a negative number and the result needs to be negative. So since it's already negative, then it must just represent negative 2. That's what students often think. You've got negative 2 and then of course this plus here, and in place of y we've got the 3. So you got negative 2 plus 3, that then adds together to give you 1. But again, this over here is actually incorrect. And again, my belief in why people sometimes do this is because they read this expression as negative x plus y. Let's read it differently. Instead of saying negative x plus y, let's read this as the word opposite. So this is the opposite of x plus y. Well, if x is negative 2, what number is the opposite of that? Well, the opposite of negative 2 is positive 2. So you end up with positive 2, and then you need to add on y or add on 3. So we add 3 to that, which then actually gives us 5. And this is actually the correct root. So in this scenario, we considered the opposite of negative 2 to be positive 2. Let's dive in a little bit deeper and in general define what we mean by the opposite of a number.